No, it's not that. It's just like the projection from many to me seems really hard. Fantastic.
Thanks. Yeah, it's a great question. I mean, we really focus on making sure we have an offering for developers really of all skill levels. And so there are a couple things that we focus on. One is our suite of cognitive services, where these are sophisticated AI models that Microsoft has built. So if you want to add, say, speech to text directly to your application, you can do it calling a web service. And so really simple to get started on that. And then sort of at the other end, we go all the way to Azure Machine Learning, which lets you build your own custom models and call them directly from your applications. And we focus there on making sure it works for all skill levels, whether you're a novice who's working with a novice who's working with automated machine learning, or someone who's experienced using the designer, or even a notebook. You can get started from there. Yeah, we really try and make sure that, wherever you are in your AI journey, that we've got something that will work for you. Always. We're constantly innovating and developing new things. There are a couple of exciting things that I'd love to talk to you more about, three in particular. First is Metrics Advisor. Metrics Advisor really brings real-time monitoring, based on AI to all of your data streams. And so from that monitoring, we'll show you the anomalous points, and you can get alerting and root cause analysis in real time. But more than talk about these things, this is why Seth is here. Seth, maybe you could help us out and show us a demo of that and see it in action.
That is correct. I am here as the demo monkey, and I'm excited to do that. So let me go over and start to share my screen here. I think this is the right one. You never know which screen you're going to share. It's always so. I think it's this one. Yes. I think. All right, Eric, how much time do you want me to do this in?
I don't know. I think we're probably behind, so you'll have to do the medium fast version.
Fantastic. So basically, Metrics Advisor, what it does is it takes time series data, such as the one you see here. This is time series data based on multiple dimensions with multiple metrics, basically tickets that come out of California, Washington, New York. We have hours, views, answers, and comments. And basically, Metrics Advisor will take this stream of data and it will create for you something that looks like this. It will show you all of the actual data as it goes, not only by some, but also by all of the dimensions. So for example, these are all of, let me scroll down here. These are all the tickets that are of type high, right? And it's all the locations. And so notice there's a ton of anomalies, and all we had to do is literally just map the data. So let me go into one particular data point. So let me go into this one here, and you're going to see that you can go to something called an incident hub that will describe the entire thing basically without you having to do anything. So here you see I found an issue at this time and day, and what it's telling me is that there was an anomaly with the data across the dimensions of high value tickets that were of type Unix that happened in New York, and you can actually go in here and diagnose and see what type of contribution it has to the anomaly. So for example, in this case, when you see this delta ratio says that it's 63.84% above the expected value for this particular time series data. And there's a ton of cool things that you can do with this. For example, you can drill into the metrics to see how each of them contribute. For example, for TAI, you can see that here. You can see where the anomaly was. And then to finish up, the coolest thing about this is that you can also do something called a hook, so that anytime there is an incident, for example, an anomaly in this case, it can alert you, send a query to an API, send you an email, etc. It's pretty amazing. Basically, you start with data, you hook it up and to Metrics Advisor, and then you have immediate insight and alerting available to you. Hopefully that was short enough.
63.84%. That was very precise. I thought that was an excellent description of it. Yeah, Metrics Advisor is great. It's built on technology that we really developed internally at Microsoft to monitor a lot of our own internal systems and a lot of the real-time monitoring for that. And so just making that available, and packaging up in Metrics Advisor. So really excited to see that. The next thing I'd like to talk about, though, is, given it's currently the COVID-19 era and everyone is, wanting to make sure that they know where they are in space and how they relate to other people, another capability we announced at Ignite is spatial analysis. And so this is a computer vision model that really looks at the number of people in a particular room, the distance between them, whether they're going into particular spaces, the dwell time that they're spending. And it's really helped in a number of places with reopening and places that want to make sure they're managing social distancing or mask wearing and things like that. So really another exciting service that's really relevant based on the types of applications people need to develop now. But yeah, we can go back to the self-described demo monkey. Sal, maybe you can walk us through a little bit more on what spatial analysis has to offer.
Absolutely. In this case, instead of showing you like the underlying part of it, I wanted to show you what it actually does visually. So there's three things that he mentioned. The first one is person counting. Imagine you're in a situation where you have to limit the amount of people in a particular room. This part of the service, spatial analysis, will tell you not only where the people are, but notice that you can see the lines that it kind of tracks where they're going. That's the first one. So just how many people are in a room is awesome, but what if we want to know how far away they are from each other? That's the second thing. It will tell you how far away from them. And you can also set alerts to tell you when certain criteria are met. So that's the second one. So the first one is how many people are there. The second one is how far away they are. And then another one, which is even more interesting, is this notion of when people are in or outside of a polygon that you define, which is even more specific. So imagine being able to use these three in combination. We have customers, for example, in New York, RXR, which is a very large company that manages buildings. They now have this running on premises because obviously you don't want this information going out, but they can run in a container spatial analysis, and they know who's coming, they know when people are coming in, how many people are in there, if they're following social distancing practices, etc. It's a pretty amazing service. So again, person counting, how far away they are, and whether they are in or out of a particular polygon. Imagine what you can do with all three together.
Yeah, it's really great, and we've worked with a number of customers in a number of different, fields as well, even in manufacturing, where they want to make sure people are staying out of particular areas, or do they have hard hats on, or the like. And so, lots of applications where being able to sort of get good analytics. In retail, I want to know how long are people spending in line, and do I need more, checkout people or the like, just from the cameras that are already installed in many stores. So, lots of interesting things that can be done using spatial analysis. The next thing the third thing that I want to talk about is the Azure Machine Learning, the Designer. So this is a capability that makes it really easy for people to develop sophisticated AI models. And this is a capability that we just recently GA'd at Ignite. And again, more than me talking about it, I think Designer is something that is best seen. And so, Seth, why don't you take it away again?
Absolutely. So for those that don't know, Azure Machine Learning Service is a comprehensive suite, or Studio is a comprehensive suite of amazing things that you can do in the enterprise with machine learning. One of the cool things is this thing called the Designer. And what's cool about it is you can actually draw out any particular complex scenario with machine learning. For example, like selecting columns in a data set, clean missing data, so the data portion. And you can also train your models and score them. From here, you can also publish your models, which is really cool. And you have a ton of data sets that you can use to start your training with to figure it out. And then you have a number of amazing tools, like, for example, feature selection, statistical functions to summarize data, and then the thing that people are most interested in, the machine learning algorithms that you can use to train these things. So if you're just getting started with machine learning, but you want to do something a little bit more advanced than calling cognitive services because you have a specialized thing that you want to do, the designer is a great way to get started so you can graphically see what you're doing, how you're doing it, and you can also publish it and create pipelines for inferencing and training.
Yeah, I find this super useful, and that notion of pipelines too. I mean, that's what the machine learning workflow really is. That it's a workflow, a series of steps that the more you automate and the more you can sort of turn them into a pipeline, they become repeatable, which helps you with ML ops, and that way I can sort of do the same thing over and over. They become scriptable, automatable, and then you can sort of batch them and do multiple models at the same time. There's a lot of capabilities that can really be lit up just by this simple expression of, hey, here's how my data flows and how I go and create my model. So a lot of really great things. So thanks, Seth, for sharing that with us. Safe to assume that no one else can hear Willem as well.
Yeah, I'm not hearing as well. Maybe we should just keep doing demos because we can't. Oh, there he is.
Now I got you. You're back now, yeah. Yeah, it's another great area that we've really embraced. You know, when we think about AI, it brings a lot of advantages, but it's up to us as the creators to know that those diagnoses are fair across, you know, races, genders, lots of different things like that. And so what they use is toolkits that we've come out with, things like Fair Learn and Interpret ML, which are directly integrated into Azure Machine Learning to evaluate the different models that they have and really see going to work in the different environments across different categories of users. And so, you know, this is something that, you know, not only do we make available to our customers, but we practice it ourselves as we go and develop all of our own models. We've put a series of development practices in place to really ensure that we feel confident that what we're developing is being done responsibly.
Yeah, personally, I'm a huge fan of the responsible AI, and it turns out that at Microsoft we have 6 very specific principles. So, for example, if you type in responsible AI, you Google with Bing responsible AI Microsoft, right? You will see like we have responsible AI principles that are super important. They're 6. They include fairness, reliability and safety, privacy and security, inclusiveness, transparency, and obviously accountability. And these are all super important. Just to add to what Eric is saying, we are super primed on doing this. These are our AI principles. Willem, can you talk to us now? Cool. So we're going to take a 5-minute break, but thank you so much, Eric. You have been amazing. The demos were on point.
they were some of the best demos I think I've ever seen. Seth, as always, it's great to talk to you, and hey, great to talk again to the global AI community. It's while we had a couple of hiccups along the way, it's always a great community for me to engage with. So really excited to be here. Thanks again.
Awesome.
Test, 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 test. Test. Okay, cool. Yeah. Say test, test, test again. Test, test, test. De noise is beperkt. Maar hij gaat uit 35. Oh ja, er zit 30 seconden vertraging in. Nog een keer test. 5 test.
Test 5, 4, 3, 2, 1.
En maak even een foto.
So I'm hoping the sign interpreters can still understand. Yes, I can count backwards. That sounds all right. At least my neural network is working still. I guess we're coming back online soon.
And Henk fixed it and he didn't do anything.
And the good thing is, Hank fixed it. He's with me in the studio today, and he didn't do anything, so it must be the AI.
No, I turned Teams on and off again.
Oh, this is a classic case of turning it off and on again. That's even better. That's so cool. And Seth is back as well. Hey Seth, welcome back.
We staan nog niet met het scherm.
Hello.
Veronica, right?
Yeah, yeah. Veronica is joining us pretty soon.
Oh, she's also.
Hello. Welcome back. So we had this weird thing happening, Seth, where we try turning it off and on again, and it works. Yeah, it still works in 2020, and I'm so happy that it does that.
Back online.
Okay, we're back online. Hey, Veronica, welcome to the show. Glad to have you. So.
Hi.
Hey. We do have sound as well. We're back, people, and it's all working again. We turned stuff off and on again, and we're back with Veronica, and she is going to talk to us about. Actually, she is going to talk again about anomalies and the metrics advisor. So, yeah. So, Veronica, what sort of work do you do during the workday?
So officially, I'm a senior software engineer at Liberty Mutual in Boston. I am currently working from home, as most of the people here, but I am an MVP, Microsoft MVP in AI. So I do lots of machine learning and AI work and research on the side. So I'm super excited to share what I figured out.
Cool.
That's impressive. Now, Veronica, I met you, but like, it was how many years ago? I think I was in Boston, wasn't it?
Yeah, it was, I think, a couple of years ago. And I think Scott Gottlieb was here with his Red Short tour.
Mm.
And from there, I actually remember that you can speak Russian.
Yeah, I mean, that was a pretty cool event. But here's a question for you. Tell us about your journey into getting into AI. How did that happen? What got you excited about it?
It's an interesting story, nothing crazy. But I was working at University of Massachusetts Medical School several years ago, and there we were trying to figure out a better solution for some of our issues, and we had an app where it basically was an app for meditation, where people needed to submit their mood before meditation, and then after meditation, it was just horrible experience. It was just a drop down basically where you choose, okay, I feel good, or I feel bad. And when I saw that drop down, I'm like, okay, my mood is down right away. So we decided to figure out how we can improve it, and that was my first interaction with cognitive services. And I just fell in love with cognitive services. I started learning more about them. So we ended up using those cognitive services, some of the vision cognitive services. I think at that time, Face API was separate, so we used that one. And then I was so excited, so I started learning more and more about cognitive services, and that's how I got into machine learning. So now I am trying to build custom models using ML.NET and other tools. And yeah, it's a fun story.
That's really cool. So basically, you started with, you wanted to actually solve a problem, you found some cognitive services, and then that led you down the path to building custom models. So tell me about the transition between calling a service and then building your own model. Was that a big jump? Is that something that all of us could do?
I think anyone can do that. I don't have a PhD in machine learning or any specific education. I don't even have like any specific background in building machine learning models. But starting with pre-built cognitive services and then use the custom cognitive services and then move to something like ML.NET. Since I'm a .NET developer, for me, that transition wasn't super hard, but definitely I had to read some books about machine learning, how what techniques I supposed to use, what tools available, and what is responsible AI, and just lots of different stuff.
That's really cool. So here's another question for you, and hopefully you can hear me. Everyone was saying they could hear the air in my room. I see this sounds bad, and now I'm fixing it. So thank you for all. I'm looking at the chat, making sure. So the question I have for you is, once you jump to building your own models, when is a good time to, like, how do I know when I should build my own models versus whether I should just use a service?
I would recommend to check available services first, since that's already pre-built for you by researchers and actually specialists who work on that all their life. And if you don't see something that is suitable for your specific project, then you can start thinking about custom solution, and then based on that solution or amount of data that you have, you can figure out what tools you need to use.
That's cool. And so here's my question to you. When you started building your own model, what was the thing that was hardest for you? Or like what was something that you thought, boy, like how would you help me if I was moving into that realm? What was like one tip you have for me?
So definitely reading about best practices and building models in order to understand how that all actually works. And then AutoML is awesome. It does lots of heavy lifting for you, and then you are getting really great models with less effort.
That's cool. Looks like we have another guest, Willem.
Yeah, Marianne is here as well. So maybe this is a good question for you, Marianne.
Yeah, I can try.
I know you are
I think I
teaching
can build up
people,
my
and especially
prior
women, to start in
or
AI
whole
and
prior
data
thought
analysis.
that I think if
Steph,
you, I'm really
can you tell us a
making
little
things
bit
for
about the learning
starters,
curve
so people
that's
without
involved with learning
any
machine learning through cognitive
mathematical
services and then
background
onto
or
custom models?
whatever you would need. So, but always with a side mark that if you really want to use the models, then get in touch with somebody who really knows the algorithm behind it, because I think that's always good to check. But the nice thing is that without having too much knowledge, you can directly start out of the box, and we will see that also later on. That basically using existing technology, existing models, then it's very easy to start. And I think as a developer, I think it's also nice that you can grow yourself. So you can also start with using out of the box stuff and then going to custom, going to writing your own code, improving things. But yeah, I would take it step by step. I would recommend you to do some statistics. And computers do great things. It's not good, I think. Yeah. Exactly, and just make sure that you have somebody aside, I would say, that can maybe help you a little bit, just to be sure, because well, the servers are getting better and better, but at the end you have to know what you do. I mean, you cannot use everything for everything, right? So a little bit of advice normally helps, and I would say look for a nice mentor, but just start building, because I think that's the way you learn.
That's awesome. So there's a couple questions in the chat that I want to throw out to you two experts that are here. Well, all of you experts that are here. The first one is from Gauthier. As a beginner in AI, is it useless to work with AI locally, or should we use the cloud for big processing needed for AI? That's the first one.
Sorry, could you repeat that question, or can we read it somewhere?
Absolutely. So if, as a beginner in AI, is it useless to start training things locally, or should I always just start with something in the cloud?
That depends.
So what, I mean, what does it depend on? I mean, help me out.
Well,
I mean,
it depends, first of all, the question you would like to solve, I would say, and the amount of data you have available. So if you have a small data set, well, then the question is it enough? Or do you just want to classify an image, and you can use, for example, the custom services directly, so you don't need any compute yourself, actually. So I think first define your question and look at what kind of data you have, and then see whether you can use already pre-built models or services. And if not, then I would say build it in the cloud, because then you can scale it.
So that's awesome, because I think if I'm understanding you right, you're basically saying yes and no. It just depends on what you're doing. And I think like what you said, I think the key insight for me is I don't think people recognize that AI is just an alternative way of programming. And so you have to start on the question. I love the answer. It depends on what you're trying to solve. So thank you for that, Marion. Let's go to the next question. What articles or books do you recommend for a person starting to use AI and ML? Veronica and Mariam, those questions are for both of you.
I can try to answer this question. I actually just read Microsoft documentation for all the tools, because that documentation is amazing. It has examples, also some samples in GitHub, right, with everything that you need, with data, with all connected tools. If it's a cognitive service, then you just need to grab your keys and endpoint and just go for it and start playing with it. I also read just a couple of books. I don't remember authors from the top of my head, but it was just general understanding of machine learning and deep learning. But I think there are lots of good online resources.
Mariam, what about you?
Yeah, I think a little bit different background. So I have lots of books on statistics and research methodology. And there's a lot out there. And let's say a starter course or a really good course, it's not specifically for starters. I think everyone who wants to start with ML was from Andrew Ng on Coursera. I think that professor is really, really great, and you learn the basics. It's well taught, absolutely recommend it. And as far as it goes for the services, I think we can all explore Microsoft Learn, and we have the whole Microsoft Docs, where you find loads of information, loads of also workshop material. You can do exercises. So that's sort of the applied knowledge.
So here's another question. I think this follows along from what you all were saying. Like, I get this sense, and maybe I'm wrong, but I see two camps when we talk about like learning actual machine learning, not just calling cognitive services, which is you should totally do because it's awesome. Some people say like we should start with linear algebra and calculus, and others say we should start with let's just build a model. And to me, it's a bottom up versus a top down approach. Which one do you both prefer and why? Do you see my question? I'll start with you, Marion.
Yeah, well, yeah, I start with the linear regression. Sorry for that, and calculus. And why? Well, I think, well, again, it depends because it depends on the type of learner you are. And I think for some students, it's really good to get those basics. And one important thing is that, for example, if you do linear regression, it's you have rules. And if you don't know the rules, the thing is that if you start using a service directly, you don't know which rules you have to apply. Now you can assume that all the services already cover those assumptions you have, but you're not sure. So in that way, I say it helps if you have some background. On the other hand, maybe that's just a step too far for some people. So then I would say just build a model, get inspired, and do your regression basics later on.
So what do you think?
I definitely agree with Marianne. That's really good point. It depends on what kind of learner you are. I can't completely distance myself from linear algebra and statistics because I had those courses in my undergrad. Because my undergrad is in computer science, so we had those courses. So I kind of had that base level of understanding before actually I started building machine learning models. But for some people, it can be also valuable to start with AutoML and start building the models, and then actually start understanding how they build after the fact.
That's cool. So another question from the audience, from George, from zero knowledge to being able to have a good grasp of AI. How long does something like that take? Zero knowledge to a grasp of AI. I mean, I have an opinion, but I want to hear your expert opinion first. Marianne.
What's your definition of a grasp? Then of course that depends.
I guess it depends. I mean,
yeah, it depends. It depends on the time of energy you put into it. Yeah, it really depends. I think I think there's sort of a norm that you need 10,000 hours to do something to master a subject. So might also work for AI.
Veronica, what do you think? Zero to zero.
I think as software engineers, we keep learning all our lives. So I can just put the deadline. Okay, you spend 2 weeks and you'll be super master in machine learning, because technologies are changing and everything is changing so rapidly, and we need to keep up with it. So it's just a constant learning process.
Yeah, so for me, like, I think understanding what AI isn't actually hard. Making AI work is hard. Just like if you know what a function is, that's easy. Like, you have a grasp of what a function is, but writing functions to do certain tasks is definitely hard. To me, machine learning is a lazy way of writing functions with data. And I feel like, and now you understand AI. It's a lazy way of writing functions with data instead of code. Well, there is some code, but that's the way I see it. Willem, so it looks like your audio is back. Is that right?
Is this for one of us specifically, or you just want an answer? Yeah. Well, as mentioned prior, on Microsoft Docs, you have all kind of exercises you can start with. And also on Microsoft Learn, you get actually also the explanation and the exercises. So you can get videos, you get the data. And of course, normally it's linked also to GitHub. So there are a lot of, as Veronica already mentioned, there are a lot of tutorials out there. And yeah, and from really easy ones and out of the box copy paste to more mature models and things.
Veronica, you mentioned that you started with ML.net. Looks like, Willem, they can't hear you right now, so I'm gonna talk over you because they can't hear you anyway. So tell us about ML.net. Is that the main framework that you use, or are there others?
Yeah, I'm mostly working with ML.NET since I'm a .NET developer. Mostly, I've been using C# for many years, and it was really easy for me to start with ML.NET. There are other options there, TensorFlow, Onyx. There are so many different tools, but for now, I prefer ML.NET.
How hard was it to pick up and actually get some models built?
For me, it was pretty easy because there is that model builder availability in the Visual Studio. Now, before you actually had to install it separately as an add-on, now it is integrated with Visual Studio, so you don't need to install anything. You just need to open the model builder. It will use other ML capabilities, and then it will. It's just a UI tool where you can just pick and choose what you want, and it will train custom model using your custom data, and then you can just use it in all kinds of projects.
That's cool. And you've been able to get stuff working just using the model builder, for example.
Yeah, definitely.
That's cool. So now, because we're about 5 minutes out before the next break, I want to make sure that I ask you both this, because I always come at AI from like I like building tools perspective, but you all make AI that people actually use, and that's the difference between me. Like I make demos and you make software. What ethical concerns do you have, or should people have, when they're creating AI-based models and using them in deployment? We'll start with you, Marion, to get us a sense for what ethical things we should have in mind when we build these things.
Yeah, a lot actually, because you make a lot of steps along, let's say, building your model. And first of all, I would say be aware of your sample. So is your sample really representing your population? And if it comes to people, well, of course, you can't just only use white male 50 plus people perfect. That's not representing the population, I would say. So be sure you make sure that your sample is correct, right, to start with. And after that, as a researcher, you make steps, right? You make decisions, so make sure you document every step and share that with another researcher, so he or she can also validate what you've done. Because I think we're all, in a way, we're all biased. So in order to get that bias out of it, I think it's very good to collaborate with others and share your decisions, actually.
Veronica, oh, sorry. Go ahead, Marion. I don't want to interrupt you.
No, please go ahead, Veronica.
No, you had a so, and I was like, oh man, she's going to say something so smart, and I wanted to like rain down the knowledge to rain down on me. Marion, go ahead. So
collaboration, I think that's good. It's a 2Rs principle, right? Two people see more than just one person. And also make sure that, because normally a solution is not a one-man show or one-woman show, right? So also make sure that your team itself is diverse, right? Because if you have a developers team of only, let's say, one type of person, you have a probability that your model is also biased again. So, and of course, from an ethical perspective, I would be really concerned about what variables you're using. What are you doing with age? What are you doing with gender? What are you doing with education level and those kind of things? Are you setting people behind, for example? So sometimes it's so easy to include a lot of data, but you have to be aware of what you're including, or socioeconomic status of people. Are you allowed to do that? So you have to talk about it, I think, and make sure you write down every decision, I would say, because then you can share it and you can talk about it and you can improve it.
Your thoughts, Veronica, on ethical use of AI?
Yeah, that topic is really popular right now, and I'm actually super happy about it. We had a table talk discussion that I had a chance to be MC at. I was at Ignite. So we were discussing responsible AI and ethics in machine learning. We had great conversation. I personally learned a lot, and it's actually going back to Miriam's point. We need to invite different opinions, people with different backgrounds, different age, so we can have input from all those people in order to understand better how AI should be created and how it should be processed better. And also, we need to remember, and we already mentioned that AI and machine learning, it is still a software. So you need to understand the whole process. You can use MLOps to deploy your models. You need to have that failure log so you understand what worked and what didn't work. And then based on that log, you can actually retrain your model to make it better. It is really important to pay attention to those as well.
That's really cool the way you both like wrap this up really nicely for everyone, because Marion, you talked about like creating the model ethically, and Veronica, you wrapped it up with, you know, just because you've made it ethically doesn't mean it can remain ethical. And so you have to continue to do operations over it, even after the model's out, to continue to improve the ethicality. This is not a real word. I wonder how they're going to sign it. The ethicality of a model. And so I love how you focus on the beginning, the process, and then Veronica, you focus on the end, the development and the ML ops of it. So I think we are done with this particular segment. Am I right on thinking that, Willem?
Yeah, so thank you very much, both of you, for answering our questions and the questions from the audience. And you can hear my audio is back again. Let's hope it sticks this time. Thank you very much again, and we will see Marion back later in the show to talk a little bit more about building custom AI solutions using custom computer vision. But first, I want to ask Veronica to, can you tell us a little bit about anomaly detection? I believe you prepared something for us. We had a little bit of a chat about it earlier this week, and I'm really curious about anomaly detection. So let's go over to that topic and see what people actually can do if they start using cognitive services in practice in their own projects.
Yeah, so good question. It's a brand new category of cognitive services. I think Microsoft started talking about a decision category only last year, and lots of services there were on preview, and this year they actually went GA. So it's really cool to play around with decision services like anomaly detector, personalizer, and then the new one, the anomaly monitor. It is still on preview, but so before that, the new one, the new service that they actually showcased at the keynote just a couple of minutes ago, there was that anomaly detector service, and I think it's the base of that new service. So it's important to understand how it works and how we can figure out anomalies in our data, whether we upload the whole data at once, like a batch of data, or we just keep uploading and have that constant flow of data, and then we constantly analyze it using the anomaly detector. And also we can connect it to different notifications. So it is just really important to understand what those anomalies are and how we can use that information to prevent them in the future.
So we're talking here about data that's not normal, actually. So in what situations would I actually use an anomaly detector?
There are so many applications for that. I think probably the most straightforward one is analyzing your data from your website, like how many people, if you have, for example, if you have a blog and you have that statistics of how many people actually go and read it every day, you can see that one day maybe triple triple amount of people decided to check your blog, and actually that is a possibility of a DDoS attack, but maybe not. Maybe you just posted a great blog post and everyone decided to check it out. So the anomaly detector will detect that anomaly, and it's up to you to understand what was the cause. But it is just the basic example. But if you are out there in like factories and you are working with more serious data, like some kind of statistical information from devices, then it's really important to monitor and make sure that nothing is broken and everything is working as it's supposed to work. Otherwise, it can be dangerous or it can break lots of things related to it.
So can you show us how to actually use the anomaly detection service in Azure to build an anomaly detector?
Sure, yeah. Let me share my screen. Okay, I hope you can see it. It is just basic demo. The data that I got is in CSV format. I got it from one of the samples on GitHub, Microsoft samples. So it's one of good places for test data if you want to check the models or you want to check how services work. So that I have that CSV file here, and then actually that's a three-part demo. The first part here is batch anomaly detection. So we are detecting anomaly in the whole data set and understanding what happened and when, what kind of anomaly happened there. And let me go to actually that method. Yeah, maybe if you don't want to have that if it's not that important to have real-time data and you are kind of do that batching process where you combine data for a certain amount of time and then you upload that batch to that service and figure out if anything happened there. Yeah, so that's it's pretty straightforward. It's just a console application that, so that's the main method I'm using here, detect entire series, and it's running asynchronously. I'm basically sharing the whole data set with the service, and then I am just checking if it contains an anomaly, then we are returning the number of that ID of that anomaly. We can return other information, but what I have in the data set, I just wanted to share so it's easier to understand. I have that time and date here, and then some kind of number. So it might be number of requests to your website. It can be a number of users on your website. So it can be different information available. And then we are. Is it better? Okay, perfect. And yeah, so we are, I'm basically just passing it to the service. And then if we are detecting anomaly, then we return that information. I can run it really quickly because the data set is not that huge. So it's going to be pretty fast. So it's already finished, and we can see that there were several anomalies, and those are IDs. We can return other information, but it's just for that specific example, I decided to return IDs. And yeah, that's that.
Yeah, so this detects anomalies. I'm getting back IDs of entities that are interesting to me. Can I blindly forward those to a user, or do I have to do perform an additional step before I can actually send it off to the user, telling him or her, hey, you've got some interesting data in here that's probably maybe a hacker trying to break in or something like that?
Yeah, it's totally up to you. If your users understand those IDs, if it's something they have access to, then that's totally fine to pass just those IDs. Or you can pass the date and time, and they can go back to the data set and figure out when exactly that anomaly happened.
And what could we do? So, for example, if I were to get these anomalies, can I use something like Azure Functions maybe to do something with the data and send it off to the user?
Yeah, that's a good question. You definitely can have Azure Functions. Here I have an example just for this case. So I am basically creating an Azure function. I created it on Azure, and then I connected it to a service, the email service. And then I am basically passing that anomaly that I detected. So now it's just ID, but again, it can be whatever is more convenient. I'm passing it to the queue, and then the function will send the message. The function will pass it to the email service, and then email service will send an email. You can send all anomalies, or you can filter them out in the code and then just send something once a day or twice a day if something happens. I can show you the setup in the Azure portal. So it's pretty straightforward. That Azure function here, and then they have out-of-the-box connection to SendGrid. So when you go and create a new function here, it can be a SendGrid type of function. And it will be...
So SendGrid is, I guess, one of the services that is exposed in Azure Functions that you can use. Are there any other options for submitting anomalies to users?
Yeah, definitely. There are several options. You can use Azure Functions. You can also use the web app. Maybe you can have an API and you send in your data there, and then it can be connected to anything you want. There are also, I know that Signal R is used for those pop-up notifications for mobile solutions, or you can send a message using Twilio. Actually, SendGrid is part of Twilio too. So SendGrid is for emails, and then they have another option for messages, so you can get messages on your phone.
Cool. It sounds really awesome. So people can just grab this anomaly detection service, then connect it up to Azure Functions. And you shortly mentioned the streaming bit where you can use just a single data point. How does that actually work?
Yeah, so here I have another function. You can use last detected data point and to check if it was anomaly or not. So basically, you are comparing it to a previous data set that you have and see if it was anomaly or not, and then return that information to the user. So you can either, again, use email or pop-up or message or anything you want.
That's really cool, and I think it's especially useful in cases where we have IoT data, metrics coming from devices, those kind of things. That's the scenario here, right?
Yeah.
Cool. Sounds really cool. And what other options do I have once I have this anomaly detection? I've heard Eric talk about the metrics advisor. Does that play any role in this anomaly detection scenario?
So metrics advisor anomaly, so it's a little more advanced. But if you just want to detect the anomaly, and maybe it's something that you work with that IoT solution or the data for quite some time, and you kind of know what might be the reason of failure, and you just need to figure out when it happened in order to understand yourself, then anomaly detector is also a good option to use. You have that functionality that you need, and you don't need to use something that you don't need.
Yeah, exactly. And do you know anything about the pricing of building a solution using this cognitive service, this anomaly detector, and maybe Azure Functions?
That's a good question. Unfortunately, I can tell you the end price because it depends on what kind of data you have, the amount of data, how often you use it. So it will vary depending on different factors. But they have really good calculators on Azure where they can help you to kind of understand how much on average you will be spending when you use all those services.
Okay, yeah, that sounds like a good idea for people that are trying to build a solution with this. Actually, I was also wondering, is there any free tier available of this service? I know there's a lot of free tier options for other services like computer vision, text analysis. Is it also available for this one?
I know they have the trial version, so even if you don't have Azure subscription, you can have 7-day trial there just to check it out and see if it works for you or it doesn't. Then for the Metrics Advisor, they have a demo website where you can play with it and figure out if you want to use it or not. There is almost free tier here, so you don't pay that much if you decide to use that service, but it is not completely free because there are other costs associated with using that kind of resource.
Okay, yeah, that's good to know. Yeah. So there's a question from the audience, and I think you will like this one actually. What if someone forces fake anomalies to confuse you or the AI? What do you do then?
Yeah, that's a good question. So you can set up your logic of your end product that it will figure out, or you can set up actually the logic that way that if you know that, okay, maybe you wrote amazing blog post and you know that lots of people will show up in your website to actually read it, then you can cover that time frame. So you basically kind of suspend all the notifications, or you are just skipping this period of time in your data, and that way you won't get notifications that you don't need, or anomalies that you probably know about. So that's definitely possible.
Yeah, so if Seth decides to retweet your blog post and share it online, and you get a ton of people on your website, you can basically say, okay, hold on, Seth is doing something special here. I'm disabling the detection temporary, and I will continue after things have died down again, and I know nothing special is happening. That's basically the option that you have.
Yeah, exactly.
Well, it sounds really useful, I have to say. I know we've talked about this before. Someone is asking, did you ever implement something like this, anomaly detection, in a case of cybersecurity in your daily work?
So unfortunately, I never use it for my day job, because we have lots of third-party tools. I am mostly doing back-end web development, and there are lots of great out-of-the-box tools, including App Inside. If you are creating your web application using Azure, or other tools that can monitor it. So it is not that critical to create a custom solution, but for I think more serious applications, I don't want to say that the web is not serious, but I feel like factories, machinery, and IoT can bring more damage if it doesn't work correctly. Yeah.
So if I understand you correctly, the anomaly detector that's readily made in the shape of this cognitive service is great to start, but once you get in a very specific domain, for example, an iron smeltery or oil refinery, maybe those kind of applications, it's better to start looking into the custom models that are available on Azure as well, in the Azure ML service.
Yeah, definitely.
Okay, yeah, that's actually pretty interesting. So, do you have any additional tips or tricks for people who want to get started with this? Where can they find the resources?
Yeah, so they can actually check out the cognitive services portal. You just Google in Bing, and then you will see lots of articles, lots of useful examples, and then also from the documentation, they provide links to GitHub samples, and there they have the data, they have implemented cognitive services, so you can see how they work, or even on that cognitive services portal, you can have samples right on the web page, and you can play with it, with those samples to understand how they all work. For Matrix Advisor, I know there is a demo portal where you can test it and check it out. So lots of good options to check it out and start playing with it.
Cool. Thank you very much. If there's any more questions that you would like to ask of Veronica, she will stick around, I guess, in the live chat and try to answer a few more questions. And just remember, if you tweet it to us live using the hashtag #SheSharpCorner and Global AI Community, you get a chance to win a gift card, $50. That's quite a large amount. I don't know if you can get Azure credits for that. Do you know, Seth? Do they accept gift cards for Azure credits?
That's a really good question. I don't know if we accept Amazon gift cards
That would be kind of
on
weird, right?
Azure.
Yeah.
But I mean, that would be awesome if we did. I got to figure that out.
Yeah, that would be actually great for people. So if also if you would like to try out any of the demos and you need some Azure credits, Microsoft actually offers a free trial subscription on Azure that gives you a small amount of money to get started. And some of the services, like for example Azure Functions, are free up until a certain amount of calls. So that's good to know as well if you want to get started with that. We're going off for a short break, I guess, to refresh our machines here and our drinks, and we'll get back to you soon, in a couple of minutes.
can't hear Willem.
Yeah.
Yeah.
Oh, we're back. Think positive thoughts, people, and send us positive tweets. Because if you do, and you add the C# Corner and the Global AI Community hashtag to it, you can win $50 gift card. And with that, thank you, Marian, for joining us again. And
Hello again.
yeah, you never left, did you?
No.
No, it was too interesting.
Exactly.
Yeah. So, Seth, I'm happy you're here as well. Without you, I don't know how this episode would ever happen.
Probably would have been awesome, but less goofy. I am all about goofiness primarily because what other way is there to be? And they told me, Marian, that I have a half hour to talk to you
Oh, wow.
about building models with computer vision. And as you know or may not know, I am a huge fan of computer vision. I started with NLP and then moved on to computer vision. So for those that don't know what computer vision is, why don't you describe the problem and then give us a sense for how you do it?
All right. Well, maybe if you're a parent, right, you have kids and they want a specific kind of toys, right? And you cannot keep up with all their main characters and favorite characters they want to have. So what if you could just use pictures and the model tells you, all right, this is character 1 or B or C or whatever. So basically it's to detect things. And in our case, thanks to Henk Boelman, who made us a really nice data set with the Simpsons Lego, actually. I thought it was nice, and also thinking about parents. I'm not a parent myself, but I do have 2 nieces, and sometimes they like to get specific stuff for their birthdays. And I thought, well, maybe this is a nice helping tool so you can recognize characters, so you know when they ask for, in this case, Bart Simpson or Lisa Simpson, that you will come home with the right stuff. So, and yeah, if you don't want to make a very complex model, you can use customvision, which is basically using the pre-trained models from Microsoft and just use it as an interface. So you don't have to code. You can just upload images. We will see that later on. And you will get an answer back. So without programming, you get actually the answer.
This is really cool. I mean, I literally had this problem the other day. I wanted to know which Simpson my kid was playing with. No, I'm just kidding. But it is a useful problem, and I love this example. I'm a huge fan of it. So should we dive in?
Yeah, I think that's a nice idea.
Do it.
So I think that I should share my screen. So let's see what I can share with you.
Can you make your font a little bit bigger by like maybe twice the size?
Well, this is not my screen actually, so.
Oh yeah, we need to go to the other.
This is so.
Yes, perfect.
Can you see something?
I sure can. At least I can. It looks beautiful. I see a bird and stuff.
Okay, good. Now you see the right screen, because I can't see the screen right now. So please let me know if I'm showing weird things. So what I show you is basically the landing page for customvision.ai. It's one of the services where you can actually use your own images, train your own model, but based on already pre-trained models from Microsoft, and then use it. So when, let's say, the standard cognitive services are not enough for you, or you want something really specifically, like, for example, I love dogs. Some people that know me maybe know the dog spotter I built, and Amy Boyd wrote a really nice tutorial for that too. But now we're going to focus on Simpsons. And yeah, of course, maybe Microsoft already trained their models also on the Simpsons, but let's just assume they don't. So I'm going to talk you through this. If you do want to do it at home, I wrote a blog about it. I think Willem will share the link to it. And I also have a GitHub repo, so you can just fork it and play with it. So let's just start with signing in. So my main problem is, if I see an image from The Simpsons, I don't know who's who, right? So we want to get an answer to that. And in order to do so, we're going to build a model, and then with some test images, all coming from Henk, we're going to test if we did the right thing. Now, I will create a new project just to really talk you through everything. So we have to give it a name. We call it Simpsons demo. In this case, recognize the Simpsons, right? And then we come to these things. I'm not going to dive into the specific variables and settings. You can read that back, but we need a resource, of course. We have to run this on Azure, so we need some resources. I created already a Simpsons one, but you have the option to create everything yourself. Now, we want to classify an image, so the model comes back with which character it is, so what class it is, and we use images that have only one image per picture. I will show you that later on. And in this case, it retails pretty good, and we do something basic, all right, just quick. There we go. And now we have basically our setup. So you can see just in a few clicks, we're done. And Hank has made a really nice website. It's a developer's guide to Azure AI, and one of his labs. Can you all see that actually? Is my screen
Sure
shared?
can.
Good.
Yeah.
Oh, sorry. Make it a little bit bigger.
They want you to zoom in just to hear if that's okay.
Exactly. So the second one is the customvision one. It's a lab. You can also build these one yourself, and you will find a nice link to the data set. So you will see this yourself. You have a Lego data set. Of course, I downloaded it already, so it's there. And I can show you that. Actually, I'm not sure whether that will be. You can't see my screen, I think. Well, don't worry. Okay, so we go back.
We can see the screen right there. Yeah,
Good.
One of them.
Good. So, and in order to train the model, of course, I have to tell the model what's what, right? Because I cannot just say, all right, this is a picture, just give the answer. So you have to do something. And this is where you can add images, and you have to give it a name. Now, I downloaded everything already. I called it The Simpsons. We have the data set, and Hank already classified everything. So in this case, we're just going to do 2, and I'll tell you how you can finish it later on. So from Bart Simpsons, we will use a few pictures. Now, at least 20, that would be really great. Actually, that's already enough. But you don't want to use everything because you want to test it later on. And of course, it's not fair when you train a model with an image and you show the same image. Yeah, of course, that's tricky. So let's say we just take these and we save the last ones. We open them, and then we have to say, all right, this is Bart Simpson. So I give it a tag. Okay, I upload them. And there we go. We have now 36 images to learn the model how Bart Simpson looked like. And of course, we want another image. Now, Seth, which image do you want?
I think I'm going to go with, of course, Krusty the Clown.
All right, good.
Okay.
We go with Krusty. So the same. We want to save some test images, so we take the upper part of it and we say, this is Krusty. Okay, there you go. Okay, good. Then we're done. And that's actually it regarding the data. Now we're ready to train the model. So we're going to train it. We do it quickly, of course, because of the demo. And yeah, here we have to wait a little while. Just be patient. Not too much, hopefully.
So while it's going, I'll ask you some questions.
Yes,
so
sure.
Basically, let me see if I understand correctly. You are building a model that is going to tell us whether or not an image that you give it is Krusty the Clown or Bart Simpson. Is that right?
So the probability, that's one of the two, yeah.
Fantastic.
Or none, hopefully.
Or none. Okay. Then the other question I have is, once you've uploaded these images, like, I'm trying to understand, is there code you have to write to get any of this to work?
No, not at all. Microsoft have done it already for you, because they already created a deep learning model, and you don't have to bother about that.
I see. And so
that's the nice part.
Can you give us a sense for what's actually going on in the background?
in the background? Well, it's chunking up the image into little pixels. And let's see it like a sort of library where Microsoft has already recognized specific things. So in this case, you're basically pixelize all your Bart Simpson's images, and then you're sort of comparing it, if that's a way to explain it. And then but of course in a more advanced way than just a human eye, I would say.
Got it.
Because we cannot we can see a lot of pictures and then remember it, but of course a model can store it.
Yeah. Okay. So basically what it's doing is it's going through some process right now where it's looking at these pictures, I'm putting in air quote, obviously computers don't have eyes. It's
looking at the picture and store it like, hey, this is Bart. And Bart from all kind of angles and maybe different outfits, or in this case we have the same outfit, but he just learns how Bart looks like.
I see. And then that way, like if you want to project this to like a business use case, you might have a situation like on a show floor or something where you want to be able to recognize where your products are, for example. Would that be I see.
Or think about a machine, for example, that has different spare parts, and you want to know which part is broken. So, for example, a person who's working on that can take a picture, and he knows, right, I have to replace this part. Also, those practical things are very handy.
Fantastic. And so for those that want to get started with this, it's literally just create a have an account, and then literally just go through the clicking that you did. Have you used this for anything other than Bart Simpson, or have you seen or have any ideas on how people could use this?
I really used it for dogs because the nice thing is that you can wrap it up and build a small app around it. So you have Power Apps and you have Flow. So basically what you do, you build a simple app and you can take pictures. And what I did is just taking pictures of dogs, and of course train the model, but also taking real life pictures and using it on my own dogs. And that was pretty fun.
Well, that's
But
fun.
I know there's also a business case. I can't tell you what, but then they're using this as well.
Got it. So yes, That's awesome. All right. So looks like it's done.
Yeah, we're done. And the good news, and of course this is sort of perfect, right? The model is very precise, so it can tell you very well whether some image is Krusty or not, or Bart Simpson's or not. So both Krusty and Bart are well represented. You can see that under here, right, this part. So actually this is sort of your perfect model. And of course you want to test the model, right?
Mm-hmm.
Okay, well actually now we can do a quick test, but you have to close your eyes actually. Well, can you? I mean, no, you will see the image. So I have to get an image. I can just browse a local file and take a new one. So this is your unseen model unseen image by the model, and it will come back actually in a flash second, and it gives you the probability that this picture is Krusty. So in this case, you've seen that, basically in a few minutes, right, we're talking, you've trained the model and you can recognize Krusty or Bart Simpson. Now, of course, we have to try Bart too, right? Because if not,
of course,
it wouldn't be. Okay, so let's take the last one from Bart, and let's see, and yay, we're doing right. Okay. Now,
that's
of course, there's a high probability, so nearly 100% sure that it's Bart. And now, of course, this is just a small model, and if you want to elaborate on it, you want to do more, well, it's actually quite easy. It's just like adding images to your computer. You say, right, I want to add more images. I, for example, would like to include, I don't know, let's do Lisa Simpson, for example.
Fantastic.
Right, oops. I have to include her. And you just add an image, and you say, right, this is Lisa. You upload it. There you go. And you follow the steps. You just train your model again. And now we're not going to wait to do that, but just to show you that you can iterate. So this is iteration 2. And as long as the series grows, you can add more images, you can add more characters, retrain your model, and just use it.
That's cool. That's cool. And so now, for example, you can literally classify any kinds of images if you just upload them and train the model.
Yeah, so you just need 20, at least 20 images. And of course you have to think about it, because I think we all know the funny picture with the chihuahua and like the muffin, all right?
Correct.
Yeah. Of course, if you want to train a model on chihuahuas or muffins, then make sure that it's as accurate as possible. So take clear pictures, and of course not, yeah, you need good material. It's still a little bit, you know, crap in, crap out, right? So
Yeah.
feed it with good model, good pictures. You have the best chance of getting a good model.
I guess the last thing you would ever want would be to eat a chihuahua instead of a muffin.
Yeah, I think so.
Here's some questions. Kira says, "What if you test an image that isn't Krusty nor Bart?" Ah.
Okay, let's do that. Let's see if I can interrupt the test.
Oh no, you can do a quick test on the iteration one.
Exactly. So we're gonna do that. So let's see. It will come back with a probability. Let's take Mr. Barnes. Let's see where it comes back with. Well, still, he thinks it's more Bart than Krusty, right? So here you can also see possible problems, right? We have, he said, yeah, it's Bart, but, and that's the difference, it's actually a low probability if it comes to the pictures that are more related to Bart Simpson's. So this would be something like, all right, the model says it's Bart, but hey, we're not as sure as normally, so something is happening. And what you can do, and you just, you know, you're starting using your model and you can see your predictions. And you can see, all right, it would be nice to see my end. I just got another one.
Okay, quick test.
Sorry, take iteration 1, and here you can see what you've done. And you can say, all right, it's classified as Bart, but hey, it's not okay. This is Mr. Burns. All right, and we will save it. So it's now out of this. It will be used to retrain the model. So in this case, you can do your own control. And of course, you can also, I would write, I think, a program for that to say, well, everything below 95% in this case, that's indicating Bart Simpson's or Krusty. Let's take a look at that. And let's reclassify that.
That's cool. So basically, this model only knows about what you tell it. And so if I were to give it a picture of Seth, in this case, I would either be Bart, Krusty, or Mr. Burns if we retrain.
Yeah, probably. It wouldn't be too difficult, I think, to get you, but we can try that.
Yeah, I mean, and that's the thing I think is important, is that this particular model is not going to do anything outside of what you told it. And I think that's one of the areas where I think folks get a little tripped up in thinking that AI does a lot more than what they think. And so, yeah. All right, so let me go through some of the questions here. Someone asked about video, and then Amy answered. She's really smart, people. She said there's something called Video Indexer, and put that up, vi.microsoft.com, for video, because it seems like it'd be similar. And then they put up some links to the other one. We also answered Kira's question, what if your test image isn't that of Krusty nor Bart? And so we answered that. So how long did it take you to get set up with this service, and how hard is it to use? Because I imagine now if you want to include this into your application, there's things you have to do to make it work now.
Well, not so many. And to set it up, the only extra thing I did was creating the resource. So basically, you create a resource group, and the resource itself, it will take you another 2 to 3 minutes, or maybe, yeah, I think 2 minutes, to be honest. And then when you want to use it, the good thing is that if it comes to your model, it's just you get a. I have to publish it, so I will publish it. That's the thing. Sorry, if not, I cannot use it. But you will see that you will get a URL. That's your prediction URL. And for the developers here, I think what you see here is enough. So basically, you have you can use the API. So this is all you need, and I think, oh, Veronica dropped out, but any other developer can see, right? You have all the information you need. You just have your image, you send it to the endpoint and give it the right header information and the prediction key, and you will get your answer back in your application. Or if you don't want to code, it's also possible, as mentioned, you can use Power Apps. And that's basically sort of canvas where you can drag on components. You have to write a little bit of code, but just some lines, right? And you use flow, and then the flow will take this logic. So you basically write out, or you drag out all the components you need to access this service, and you send the value back to your application.
It's really cool. And I will say, I have used this service. One of the cool things, and you see, why don't you click got it? You can also export these models. And I built one that looks at me, from a web page and tells me whether I'm having a rock, paper, or scissors symbol up. So I can play rock, paper, scissors against the computer. I have that demo. It's fantastic. And it's all running in the browser because you can actually export these models.
And you can also put it onto a Docker container. So basically you can play with it as much as you like and pack it in the way you like to work with it. So from really not zero code, but let's say 1% coding with Power Apps to everything you want to do with it.
That's really cool. And like I said, those can be downloaded and you can actually look inside of the models. There's a really cool program called Netron, if you look that up. And if you download the Onyx model, you can actually see what's inside. So a couple of questions. One, Matt, his wife is doing research about coding infant and parent interactions, reading babies' minds. I wish I could read babies' minds. That would be awesome. Another one, use case at a bank to greet customers as they come in. Do I need that many pictures of customers to train the model and identify the customer? Customer recognition, is this a good service to do that kind of thing?
Well, there we have the ethical discussion, right? Yeah. Your customers would need to give their permission for you to store the information, to use the information. You have the probability to take the data away to retrain your model. Now, all that is possible, of course, but you have to think about it, because you cannot just take pictures of your customers. So in theory you can, right? Because you have all the CCTV and you can just classify your customers, train it so you can recognize the customer. But I think this is a nice ethical question.
Yeah,
would it be correct to do so?
I guess it depends, right? Like, for example, like when I talk to my phone, it looks at my face and I'm okay with it because I told it. So that's a really good question. Mohammed, looks like it is indeed possible. I know there's services that will do that. But again, you have to think about the ethical concerns there.
Yeah, but think about, I said maybe not a bank, but what, for example, people that suffer dementia, right? Maybe they don't recognize their own family members. Now, in that case, you could build a very simple app to help a person recognize his own family members. And of course, you need all the consent from everyone. But if you get that consent, then this might be really helpful for people with memory problems.
Correct. Someone's asking about the resource. I'm going to put it there in the chat. Again, I think that's the right one. Let me double check it here. Yes, indeed. That is indeed the right one, but it's a different, that's an object detection one. Apologies. But Amy posted some really good links there for all of them. Make sure you do that. Look at those. Mary, anything else to finish up before we start transitioning over to the next session that I'm super excited about?
I would just like to invite everyone that's really new to AI. I mean, just start and take your starting path. But by building these kind of models, you've seen it. It's not fake. We build it live. You can do that yourself. And so don't be afraid to start. Don't be afraid of all the math or whatever. You can see that basically in a few minutes you build your own models and go play with it, I would say.
Awesome. Well, this has been fantastical. Willem, we're going to turn it back to you. Do you have any other questions for Marianne before she goes off and does more amazing things?
actually? I'm just.
That's a good
without
question.
words. It's
don't
amazing
know.
to see the stuff that
The
you can
answer
do
is
with,
yes.
custom computer vision.
That's
So
good.
one
You can
last
upload
question that I
images
have
via
is
an
actually,
API.
so if I were doing DevOps in a regular application, is there any API that I can call to trigger the training cycle on this custom computer vision service?
Quite amazing.
I have to take classes from you, Seth.
Well, maybe I should take classes from you, and then we take classes from each other.
Sounds
It's like
good.
learning. It's so cool. What? Why don't we do something? We should do something where we like all get together and then maybe stream it out and maybe talk about the stuff that we know. We should do something just like that. I mean, okay.
Oh, we should
Okay, let's do
definitely
that.
get back together
like a
next
plan.
year and have a cup
maybe
of
let's
coffee
just do
and
it right
sit
now.
down to hack. I mean, yeah, I think well we've got some plans, so we'll get back to that in the next few months. Yeah, cool. Oh yeah, let's well maybe let's wait for a little bit because we have our next guest coming up, Richard Campbell. He's going to join us, and he has a pretty interesting talk about the history of AI. Actually, we're going to look back at how it all began and how we had these winters, and it's like the Ice Age in here. So I'm really happy to have you, Marion. Thank you very much for the cool demo and showing us all the stuff and how you got started. Do tweet us the questions. Remember to include the C# corner and the Global AI Community hashtag in there because we're giving away free stuff. $50 gift card from Amazon.
Hey, I'm here. I'm well, sir. How are you?
We're choosing the best, the most funny tweet.
And look, my audio worked and everything. We have a good technology moment, so far things are working well.
Well, Richard, your
I
voice
think it would
always
have
works across all
Richard
technologies.
online that we can
Yeah, I wish that was true, friend, but
Hey,
the
Richard.
pile of gadgets involved in
How you
making all
doing?
this look work well is not trivial.
Yeah, pretty good. We're having an exciting evening here.
Mm-hmm.
Yeah. That's not at all. You should see the set that we have
Well,
over here.
I find myself
we're
doing
running,
history work a
like
lot
5
these
laptops,
days,
but
not
then
only
the
around
other
.NET and
resources
web
to get this
development, but
all
the
working,
AI
and as
conversation is
people have
fascinating.
earlier in
In fact, the original version of this
working
talk
their
I
day,
did for the
that
Vatican,
doesn't always work
I
together
participated
very
in
nicely,
a
but
startup
it looks
accelerator
like
at the
it's
Vatican
working,
called
so
Laudato Si,
I am curious
and
what
the
you're going to
Cardinals
talk
asked me
about,
if I would
Richard.
talk about artificial intelligence. Now, I know this is a very different crowd. I mean, mostly when you're talking to Cardinals, you're talking to quite elderly men who are not particularly technically savvy, so there was a lot more explaining. But I think, well, looking at the quality of questions coming from this audience, they're a lot more experienced and a lot more technical. So this is tuned differently. I definitely want to hit some of the highlight points that have happened, I think, over the past 70 years that have led us to this moment in 2020. It's true. And me too. I mean, I know I look older, but I'm not that old. But, you know, the interplay between the hardware, the software, and the various philosophies that got labeled with artificial intelligence is interesting. It has twisted and turned a number of times.
Oh, wow.
All right, well, shall we put this, let's get the slide up. I'll get the screen sharing piece working and make sure I share the right screen because there are many. I know you recommended we have 2 monitors, but I'm not a 2 monitor kind of guy, really. So there's many monitors for me, but that's not a bad thing either. And thanks so much for letting me participate in this. It's a great conversation. It's something I think is really important because it's easy to look at the extraordinary set of technology we have in front of us today and just say, and not be clear that we are building on the shoulders of giants, many, many giants. And I want to start the story with one of the giants of computing of all time, ever, Alan Turing. So Alan Turing is not the only person behind modern computing, but he's one of the principal people. And he did not coin the term artificial intelligence, but he did ask the question in 1950 in a paper. He said quite simply, can machines think? And he described this concept of what he called the imitation game. We would later name it the Turing test, but he would certainly have never named it that way. And so you think about in 1950, the World War II is not long past. They're still doing recovery. And the modern computer is not really born yet. We have computers, but they are pretty bespoke. They're all one of a kinds. Programming them is quite complex. We're only just beginning to get to the idea of programming languages. And already the question of can machines think is starting to surface. And that paper is referred to as sort of a seminal work that leads in the 50s to broader conversations. And so the first time you really hear the phrase artificial intelligence is in the summer of 1956, when a gathering of these computing scientists, mathematicians, and engineers started to think through, can we create an artificial intelligence? Now, this was in Dartmouth. Marvin Minsky and many others together. They've certainly celebrated all of this. Now, that's only in academic circles that we really see that concept. And they start with experimentations in, again, early machines. And a lot of the funding for this comes from the military. And so they've been sold this idea that we can build this remarkable machine. They're already predicting by 1956 that in the 1980s, artificial intelligence will be solved, that we'll have an intelligence. This has always been this play of trying to get funding to create something profound. And along the way, various technologies emerge. And in that time, a lot of the most important things that were invented had more to do with logistical planning, which the military needed a lot of and continue to use. The intelligence part, that's a little more complex. And in the 1960s, funding is starting to wind down, but computing is evolving. And I think one of the cornerstones of that was an important man by the name of Gordon Moore. And in 65, he wrote a paper as well. And in that paper, he talked about the beginning of the microprocessor, which he'd been helping to invent. And he said he noticed a pattern of behavior that for a given amount of money, the amount of transistors you could put on a piece of silicon doubled roughly every 18 months to 2 years. Now, he didn't call it a law, he called it an observation. He certainly didn't call it Moore's law, other people called it that. But it was this observation of this doubling of computing potential, not necessarily speed, but really for a given cost, the amount of technology that we packed onto a chip expanded. And I bring this up for a very important reason. The evolution of artificial intelligence is bound to its hardware. And so the iterations of hardware ultimately open new doors to the potential of computing. Now, this is still a largely academic exercise, and it's taking place mostly in universities with very large, very expensive computers, where every minute of compute time costs money. And so you're seeing scientists pursue grants to do these experiments. Now, by the time you get into the 60s, we're getting some pretty interesting pieces of software. And Joseph Weizenbaum in 1964 built an app he called ELIZA. You could call this the first chat bot, and it was invented even before I was born. What it was actually doing was simulating what was called Rogerian psychotherapy. This is after a psychotherapist by the name of Carl Rogers, who was famous for sort of parroting back what the patient said to get them to explore it further. And this has been a sample application that has followed us around for many, many, many years. I've seen this on PCs and so forth. Even this screenshot is from a much more modern implementation of the one that it once existed in the 60s. What's interesting about these early days is already we had these pictures of entities in artificial intelligence, and it pressed against the human's tendency to anthropomorphize. Fundamentally, humans sort of look for humanity elsewhere. We look for faces. We see them everywhere. I mean, folks see faces in trees. They see them in sporting equipment. They even see them in mountains on Mars. So we are prone to giving entity or agency to these tools that we've created, even though they're not really there. And the ultimate manifestation of this, and really the first time that the phrase artificial intelligence appears in the social conscious, in the broader population, is in 1968 in a movie called 2001: A Space Odyssey. Now, this movie is important for a bunch of reasons. In fact, most directors that make space movies still refer to this movie as sort of the definitive work. Kubrick, as much, whatever you may have thought of him, he pushed the envelope. Before man had landed on the moon, he had already made a movie about mankind living in space. And he had commissioned Arthur C. Clarke as his futurist. They actually collaborated over making the movie. The book would come later. So this was not a book adaptation to a movie, rather it was a vision of a movie that became a book. But Arthur C. Clarke is a futurist. He's passed now, but by that time, he had already written about geostationary satellites a decade before they could be built. And they talked about machine intelligence, and they used the phrase artificial intelligence and said that by the year 2001, we will have machines with intelligence that have matched or exceeded humans. Now, the downside to this, as cool as it may be, is, of course, that artificial intelligence, that first time that it's seen in the public, the machine tries to kill everybody. And so we set a tone right from the very beginning to the rest of the world that, yes, we're going to make this artificial intelligence, and yeah, it's going to try and kill everybody. You know, Terminators, all those things will come later. But for better or for worse, for us as technologists, we've kind of set ourselves up into this current challenge. And I'm not saying the ethical debate isn't important and something we absolutely need to focus on, but understand that popular culture has also grabbed onto this anthropomorphization and created perceptions that are incorrect. If you're working in this space, you know these things aren't true, and that we don't have artificial generalized intelligence. We're still exploring what that would even mean for us. We build specialized intelligences. And so more often than not, when you end up talking in public about artificial intelligence, it comes across more as artificial stupidity. And by the end of the 60s, the promises that had been made in the 50s didn't measure up. And again, I think movies didn't help that here we were able to create these simulations of intelligences, we just couldn't actually build them. And so a lot of military funding and general funding dried up. And this is the first time we hear this phrase, AI winter. So the decrease in funding. Now, it didn't mean that the technology never worked. They did build important and powerful things that benefited the folks that were using them and continue to this day. The logistical engine of the U.S. military is a profound capability that exceeds every other nation in the world. And the technology still continued, but the money that was available for research and inside of universities, not as much. And so when you get to the late 70s, after a quieter period, you do see a new generation of what was then wrapped in the AI banner again. So this is the expert system model. And this is in the late 70s, early 80s, which is also the emergence of the personal computer. So when you think in terms of the Apple II and the IBM PC, that Gordon Moore has driven down the price of compute to the point where you can have a machine on your desk rather than require university scale machines. And so this generation of expert systems where they're capturing expert knowledge largely in decision tree models, so call it almost like a super ELIZA, where it's just able to answer questions. But in order to have them run fast enough in those early computers, they're building custom super PCs. And so by the late 80s, there are a set of machines they called Lisp machines because they were largely programmed in Lisp. And where the typical IBM PC of the day was $3,000 to $4,000 US, these are $50,000 to $100,000 a piece. And there's about a dozen vendors selling them. And they're not delivering the value for the money that cost. At the end, by the 1987, sort of the end of this generation of computing, about less than 10,000 of these machines have been sold, and most of those companies go out of business. And so you get a second AI winter towards the late 80s. Now, all the models I've talked about so far were very much decision tree models. ELIZA is certainly a decision tree model, and all of these expert systems fall in that class. And it brings this conversation forward that emerged at that time around this concept called the neats versus the scruffies. So the neats, and let's face it, we're talking about Seth Juarez here. He's very neat. Are about logical and symbolic reasoning. So creating complex algorithms that have repeatable steps, that are logical and validatable, Lisp and Prolog being good at that. This is most of the activity that happened up until now. But there was an emerging group, the scruffies, that said that intelligence is just too complex to adhere to neat methodologies. And so now they're getting more into the neural net models, object and inherited models that created their own complexities in the sense that they were harder to measure, harder to validate, but they created remarkable results. Now, we know today, with the benefit of hindsight, that in the late 80s, early 90s, when they were talking about this, the scruffies were going to have a good day. But it didn't mean the neats didn't continue to progress. And by 1997, you get, I would argue, one of the greatest wins for the neats of all time in a computer built by IBM. So notice we've moved out of the university now, and we're talking about research groups and large corporations. The project was called Deep Blue, and it was to make a grandmaster class chess player. Now, the performance of this machine, you can see the size of it. It is taller than you are. It's about an 11 gigaflop mini computer. And I would point out in 1997, 11 gigaflops is a lot, but that's about the same horsepower as an iPad 2 circa 2011. But it did beat Garry Kasparov. It became the best chess player in the world and considered a remarkable victory. Now, again, IBM continued on. This technology is the origins for Watson. And Watson hits its peak in 2011 with its ability to win at Jeopardy. And so the Watson technology continues today. You can participate in it if you want. They have a lot of licensing opportunities, and they're heavily into the medical spaces and so forth. But it is important to remember that it falls into the needs category, very much the decision tree models, and they've really stretched that model to the lengths they possibly can. Let's change gears and jump to the scruffy conversation. And I want to talk about one particular scientist, Geoffrey Hinton. Now, I have my personal biases toward Geoffrey Hinton. He happens to live in Canada, as do I, although he's originally from England. He got his PhD in AI in 1977. Not a great time to be an AI researcher. I think it was a very challenging time. But he was one of the folks deeply inured in the neural net model that the scruffies loved so much. And by the 80s, in that time of the list systems and so forth starting to end, he was talking about the fact that neural nets were in the 80s were just not sophisticated enough to do the kind of work they needed, that he'd come up with a mathematical construct called backpropagation that opened the possibility for much deeper neural nets, but sort of ends that paper with, these computers aren't going to do it. They're not strong enough. And so that quiet period for neural nets, and that's in that second AI winter, these deep neural nets, they don't go anywhere for a few years. It's actually students of Geoffrey Hinton's who sort of dust off that old paper from the 80s and start working on a new problem, thinking the compute is now there. So we've got a new generation of computational power. And so in the 2000s, there was a new competition. So this is the ImageNet Large-Scale Visual Recognition Challenge. Started in 2010. Taking advantage of the cloud and the internet and availability of data, it is a collection of 14 million hand annotated images. So it's a set of images that are already identified, tools for training with. And the competition was to build software that could recognize those images reliably. And in the first couple of years of the competition, 2010, 2011, virtually all of the software were decision tree solutions. And the best they ever did was 74% recognition accuracy. Not bad. Humans do better. Not great. But Hinton's group in 2012 implemented a deep convoluted neural network. And they ran in the competition on September 30th, 2012. And their first attempt during the contest, got an 84% result. By 2015, it was 100%. And so in that sense, the scruffies had their day. The best the decision trees could do on this was quickly superseded by this modern neural net model. And it opened the door to a huge explosion of technology. When I think about artificial intelligence today and this new spring that we've been living in, it starts here with this image recognition. Now it quickly moved over to voice recognition because, one of the beautiful things about the academic model is the sharing of the papers, the sharing of the core concepts. And so very quickly, other organizations picked this up. And so looking at voice recognition, the emergence of Siri roughly in that same time. So SRI was the company, largely an offshoot of a DARPA project that was acquired by Apple using the convoluted neural net to do voice recognition. And voice recognition had existed for years before this, but it was much more that decision tree model, and it required a lot of training. It was much more difficult to make voice recognition work. And then along came Siri, and it just worked, unless you were Australian, because some accents are harder than other accents. But that Siri, Google Voice, even Cortana, all roughly along the same lines. And what had happened was voice recognition in the old models that were 93, 94% accurate suddenly jumped up to 99% accurate by switching over to that neural net model. There's an interesting pattern that's happening here over and over and over again in the evolution of artificial intelligence. And I've got this diagram that I found that sort of breaks it all down. Artificial intelligence seems to be the name of a technology that when it is in its immature state, or rather when it doesn't work. The moment it does work, it gets a new name. So if you look carefully at this visualization, you notice sort of in the middle there, the planning, scheduling, optimization, the technologies that were worked on in the 50s and the 60s by Minsky and their folks. So the shortest line there, and then the expert systems from the 70s. And I haven't really talked about robotics, but that's also from the 70s when robots really appear in manufacturing. There's robots existed before the concept of artificial intelligence. There are some integrations there, but they're kind of their own thing. Speech systems have been around a very long time, but they were transformed by the convoluted net. And now we have these, as these technologies are spun out, we've given them new names. Our image recognition and machine vision systems, our new ability to do natural language processing, even to the point of translation and doing classification, sentiment analysis, those sorts of things. And ultimately, in our modern version of machine learning, the deep learning predictive analytics models. And it's the hardware that's made the difference here, but not just the hardware, how we utilize it. The importance of the cloud in expanding the opportunities for artificial intelligence. Because often our training models require huge amounts of compute for a relatively short amount of time. And so we would still be confined to a few small areas in the world with that kind of compute available and sort of restricted access to it that would limit the expansion of artificial intelligence. The cloud leveled the field that anyone could build a model and rent that computing power for the short amount of time they need it for a reasonable price and then execute on their models. And there's only been a few occasions where we've seen major artificial intelligence events occurring that got us to a point where even the cloud was straining. But compute has continued to expand. The evolution of the GPU and scalar computing, optimized machines for these kinds of neural net models, brings us closer and closer to the diversity of being able to do this in almost any location at any time. I also think the availability of data has a huge impact. And for better or worse, we have to point to social media as the impacts around that the tendency for more people to put more data online where it's readily available has provided mechanisms for us to train more models in more ways. All of these things have worked together to get us now to just a few years ago. And sort of talk about this next generation. So 2011, 2012, 2013, very ascendant models of those original concepts of Hinton. And I don't want to put this all onto Geoffrey Hinton. I think he's an extraordinary man, but there are a number of extraordinary people in this field that ascended all at the same time. I do want to talk about Go, because I think it's got a great corollary to the success in the 1970s by IBM with Deep Blue. Go was considered an impossible game to model, certainly in the decision tree model. The 19 by 19 grid games are deeply cerebral, very complex games. You can't brute force your way through a computational model on Go. It's too many possibilities. The Google folks took it on with AlphaGo in a neural net model, and they spent 2 years training that model, teaching it games. And so by 2016, it beats a world champion class. And of course, the famous event is in May of 2017 when KG is beat 3-0 by AlphaGo. Another ascendant moment, but they didn't stop there. I think what's more interesting still is AlphaZero, that they took the approach that they did with AlphaGo, which took a couple of years to build, was sort of very traditional training model. And here with AlphaZero, they used a much more sophisticated approach in neural nets, the adversarial approach, where it actually played itself for 40 days, knowing only the rules of the game, rather than having looked at many, many games the way you would typically train a model. And so that in that short amount of time, it was able to beat AlphaGo against playing Go. They also did a demonstration, and this was just a couple of years ago, where they put it up against a chess program, Stockfish. And not only did they show that it could beat Stockfish in a relatively short amount of time, but that the computing resources required to run the model to beat the best digital chess players was hugely lower, that it was a much more efficient way when you have a good model to actually execute these kinds of complex problems. Now, there's still some conversations around what this all looks like, but it speaks to this ongoing evolution of AI in more and more sophisticated models. Now, I was going to steer largely clear of robotics, but really getting down into sort of the closer and closer to the current times, I want to talk about MIT Dactyl. So this is a robotic hand for manipulating objects. And we know that training models takes time. You have to do it over and over and over again. And so as soon as you start talking about training articulation like this, it can take impossibly long. What the MIT group succeeded to do with Dactyl was to simulate the hand in a virtual reality model. And so to allow it to practice the manipulation of an object in a digital realm at much higher speeds, the equivalent of hundreds of years of practice, and then to take that model, implement it physically, and have it have the same articulations. So this is, I think, a transitionary model we're starting to get into, where the fact that we can create physical representations of those learnings, not just identifying images with probabilities or simulating voice or recognizing voice or any of these far more intangibles, but to actually have physical activities now be manifest with that same kind of training in a virtual realm. That, to me, is barely history. This is a year or so ago that we're getting to this level of experimentation, and it opens the door to new potential. But it opens a question, which is, are we continuing to evolve? These are mostly engineering exercises. Fundamentally, we look at gains in the modern neural net. We're engineering with those now. We're doing bigger and bigger projects. Organizations like Microsoft and Google and so forth providing us tools so that we as engineers can take these technologies and implement them to provide benefits to companies. But there's a conversation of, are we expecting another AI winter? And folks like Jeff Hinton have talked about the fact that there's another AI winter coming. But what they're really talking about is that the money being spent on research is starting to diminish. Now, I would point out two things. One is, in all the winters that I've talked about, it's not like the work disappeared, and it's not like work didn't continue. The rates changed. I think we've hit a period now where we're getting such good results with the technology we have that there's the energy to do research may be diminishing somewhat, so that perhaps there's fewer new innovations. And notice really not a whole lot of conversation about building an intelligence either. We're still using these technologies to build tools to do useful things for us, but not necessarily to be that tremendously intelligent. I would argue that we are still in a springtime or in a summer where we are providing value to organizations using a technology. And as long as we're doing that, as long as we're taking that technology, creating unique value from it, our work is going to continue. The rate of innovation waxes and wanes with need. I would argue the pandemic has put a lot of pressure on us as experimenters to show value rapidly, and that tends to diminish broader research. But that's okay. This is a special time. Providing value is important. It's good for us to have a retrenchment, think about the value. And at the same time, when that value starts to level off, we can do some more exploration. thanks so much for your time on this. I've really enjoyed talking about it. It's one of my favorite subjects, and I'm hoping to stick around for the next half hour or so and be part of the panel coming up.
That was awesome.
Thanks,
I'm glad I'm one of the neats and the scruffs.
You are a neat set. Well, you know, folks, I don't know the folks know, but I certainly know you have a degree in mathematics.
I did get a master's degree in computer science, and people don't know I was a doctoral student, and I studied machine learning when the NEETs were kind of still in charge, and my models were very mathematically beautiful, and I have always struggled with neural networks because mathematically they're just not like perfect.
Anybody I know that has a strong mathematical background, they loathe the lack of a proof. They just don't believe it unless there's a proof. And neural nets are remarkably resistant to proofs.
It's a problem, and people don't know. There is an entire theory around all machine learning models except for the neural networks. Like there's something called PAC learning, which stands for probably approximately correct, where you can tell how many data points you need for a particular model to give you the probability that it's the accurate percentage is something, right? So, and you can literally mathematically define that. And there's something called VC dimension. There's an entire and this is Chernovenskis and Vapnik came up with this stuff in the 90s. And so when I studied machine learning, it was like, okay, there are some pretty cool things. Like I love SVMs because they're mathematical beauty. And I've talked to Turing Award winners about deep learning, and their answers tend to be quite squishy.
Yeah. And it's not normal, right? You think about in the arc of people that I was describing there, guys like Turing, and I didn't mention von Neumann and so forth, but long before the hardware could do the computations, they had built the models for computation, right? The Turing complete computational model was an important part of knowing you'd built a valid computer. And so the fact that we're struggling with mathematical proofs around these neural net models, it's deeply concerning for the validity of the process.
And it's very squishy. Like, here's an example. Simple mathematical example. Everyone has heard of a parabola. It's a big U.
Yeah.
If I were to ask you to mathematically give me the minimum value of that function, it's easy to do.
Yes, of course.
Derivative, set it equal to 0, it tells you where it is.
It's the bottom of the U.
Yeah, and those are called convex functions because they basically have a single answer. The thing about neural networks is that they are non-convex, complex shapes in multiple dimensions. And so there's no way to know, number one, are you in the right bottom U? Because you might just be in a hill or a little valley if there's a deeper valley. And then the other question that I've always had is, like, how do you empirically, it's only empirically, but you have to empirically figure out how to structure these models. And I asked a Turing Award winner, how do you know? And he's like, well, you kind of just do what people have done before and you go from there. And I was like, you're like a world-renowned expert in deep learning.
And you're saying the answer is close enough?
The answer is like,
well, you know, I mentioned Arthur C. Clarke early on in 2001: A Space Odyssey. He's also the fellow who said first, any sufficiently advanced technology is indistinguishable from magic. And here we are. There's now literally magic as a service.
It almost sounds like,
and that's what worries me
to me.
Because anthropomorphization of AI is probably the worst thing we can do for ethics.
Well, without a doubt. And we give this technology credibility that we don't have. Well, the machine said, so it must be true. We take the errors we have made in our past, stored as data, build models around it to amplify those errors.
Yeah.
Amen. And I was in a panel once, and I think I got invited to the wrong panel. It was like in Texas for like educators, right? And like there was like other company salespeople, and I was like, I think I'm at the wrong meeting. But they were talking about AI in such a way that I was like, hey, friends.
But I'm going to stay.
Sorry to bring this up here.
Yeah.
But we're humans. You draw a face on a rock with a Sharpie, and our immediate reaction is, oh, it's happy. No, it's a rock.
It's a rock.
And people get mad at me. They're like, "Well, you're calling AI a rock?" Yes, I am.
Yeah.
It's a rock
It's a
that
rock.
has data burned into it in a way.
It's a very fancy rock, but it is still fundamentally, it's a tool. It's a tool we made.
Yeah, and then everyone all of a sudden were like, "Oh," and then the sales dudes from the other companies were like, "Well, I don't know what to say after this. How do we sell this?"
And therein lies the problem. Like we've taken a lot of technologies that already existed and bundled them under AI because it was hip and it's profitable, right? You know, you had the joke of the beverage company that just added AI to the name of their beverage and sold more. It's like, you know, it's just a naming strategy. And so, you know, there's a downside to that, which is that it does tend to distort things. But I also appreciate that as soon as it's a viable product in any way, you give it a new name. It gets pulled out.
That is true, and that was interesting. That little that chart that you did, it was interesting because I was like, oh yeah, once you give it a name and you strip like the mystique out of it, you can make a pretty good living off of it.
And this is where I make salespeople upset and say, we use artificial intelligence. It's my experience is anything labeled artificial intelligence is stuff that doesn't work. When it does work, it gets a new name.
And that's why I guess I am an AI cloud advocate, because I really don't work.
Haven't worked for years, Seth. We've done stuff together now for more than a decade.
That's right. And I haven't worked a day in my life.
And you'd be true.
You know, you have way too much fun. We can see it on your face.
That's right. That's right. Well, I'm sorry, I'm talking, Richard. We get into these discussions sometimes, and it's like,
yeah. This is unfair, Willem, because we've known each other so long. I mean, I can tease him endlessly, really.
That's right. There is endless things to tease me about.
It's true.
And I have to
Very
say,
true.
in this case, since my sound is really bad today, I'm really happy that you're having this conversation, actually. And I'm learning a lot from this one, especially. And it's totally fine. So I've got a question. We talked about these neat guys and scruffy guys. Do you see any crossovers happening from the scruffy guys to the neat guys? And I have to say, in this case, since my sound is really bad today, I'm really happy that you're having this conversation, actually.
Well,
and I'm learning a lot from this.
Are you asking does Seth swing both ways? Yeah, I think he does.
I do. And like, if I were to go back to school and finish, again, I was a college dropout. If I were to go back to school, I would literally spend the next 7 or 8 years trying to come up with formal methods or verification methods for neural networks. Maybe, for example, pack learning works in some way, shape, or form with deep learning. Maybe there is a structural model beyond deep learning that we can use, because in the end, it's all dot products and functions and like vector subtraction. I mean, that's all it really is.
I had read some of the papers coming out of the explainable AI effort from DARPA that very much they were talking about that particular problem of we're trying to understand why neural nets are coming to the decisions that they are, where they find their probabilities, and they were using decision trees to explore the neural net. Like, it's just interesting to me that those two disciplines feed against each other ultimately, or could feed against each other ultimately, to help them both be better.
Here's the kicker. People don't know this, but when it outputs probabilities, they're not actually probabilities. They just put a function at the end that forces them all to sum to 1.
Yeah. It's just a number between 0 and 1. Never 0 and never 1.
Yeah, and it's crazy that people are like, oh, here's the probabilities, and like if you talk to a pure statistician, they'll literally just be like, that's it. They'll throw their ball on the floor and leave the house, right? Because there was a cool meme. There was a cool meme I saw. Like, there must have been a bar fight somewhere, and people were throwing chairs at each other, and the statistician said, looks like somebody just said machine learning is just applied statistics, and everyone's throwing chairs at each other. Find it, I laughed for years.
Just a bunch of if statements?
Yeah.
So would you say
Yeah, I think so. I mean, we're in the end, we're ultimately doing the engineering of applying these things and getting useful results. And every time we do that, I think we help to some degree to validate things. There's plenty of bad models too, right? I do feel like our profession is being improved by the challenges of dealing with data at this scale, right? That we have, the ethical conversation has always been there. We're now surfacing it in a much higher level. And it is part of this is the anthropomorphization effect. When we threw the word intelligence in this and we are handing these tools agency they ultimately we should not have, it's made us look back at ourselves and say, these are not the data's biases, these are our biases that are manifest in data. And now we're using tools to amplify them. And I've used this line in the boardrooms, like computers are only amplifiers. They can amplify your intelligence or they can amplify your stupidity. Which would you like?
Yeah, and I would add that even in my limited look at Lyman Schaap, they're basically looking at a model post facto after it's been built. Like for me, I would like to know more about it pre facto. Is that a term? Right? Like I'd love to know like what is the power in this thing. For example, like I said, there is something in pack learning called VC dimension, where like a certain machine learning model can shatter a space. It's called a shattering, and you use that how many spaces it can shatter to do some approximations. That's a formal method of looking at models, but you can't do that with deep learning right now because there's no way to know like what the VC dimension of a particular deep learning model is because it's so variable, and that's like those are all post facto. Let's look at a model after it was built, as opposed to what is it that we're trying to build and how expressive is it?
You know, I wonder if it's almost a nutritional content problem, right? It's like you don't eat the food and then decide whether it was good for you or not. You kind of read the label, right? We've created a construct that says this is the contents of these things, this is the nutritional value. And I'm starting to feel more and more about that, about data. Like I don't want to read this data until I know its basic qualities. I need its nutritional content. Because then ultimately these models would be manifestations of the sources of information. And so if we qualify the sources of information, we should have the potential for better models.
My advisor in grad school, Hal Dalmay, you can look him up. He co-authored a paper called Data Sheets, which in theory is supposed to solve this problem. In essence, what you do is you have a data set that is accompanied with a thing called a data sheet that says, this is what we were thinking when we made this data. This is what's in the data. This is where we got it from. This is the segment of people that it came from, right? And so that's an interesting idea, but notice that's an interesting like human approach to it. But again, there's no mathematical way to show.
The way you described it sounded like intent rather than content. Yeah. Right? What's actually in the box.
And those are called data sheets, and you can look that up. There's also something called model cards, which are similar things, but that describe a particular model. And this is the research that's going on right now. But to me, like you hit the scruffs versus the neats thing very well. Like it doesn't hit me in the right spot. You know, it's like I feel like it's still too fuzzy. Right.
Well, and both of them were consuming data largely from similar sources. So we still have this overarching problem. And every data scientist I've ever spoken to says the same thing. It's like you spend 80% of the time validating the data. In some ways, the model's kind of the easy part. Do you know what you have? Do you know the nutritional content of this data set?
Yeah, and that's the rub. Most people don't. And then because they don't, whatever bias is burned into the data. I'll give you a simple example. And this is, I can find you sources later on, but it turns out that in the United States, we over-police a certain segment of our population. So if a police precinct were to say to me, Seth, I want you to build an AI model to tell us where we should go find crime. Well, if I use their data, what do you think it's going to tell them to do or where to go? Right?
Wherever they went before for crime.
Yeah, and it turns out that if they over-index on a certain subpopulation of American citizens, the model will say, "Yep, that's where we go to find crime," because it turns out that if you're looking for crime, you're probably going to find it, and if
Yeah.
you are looking in a specific place every time, then all of a sudden there's a double problem, right?
Yeah.
Now you have computers saying that these are where the crimes happen, and that's
And
just a
then you
simple example.
But then, and it gives it this credibility. It's like, it came from the computer, it must be correct.
So Marian, you're working with AI on a daily basis. How do you, for example, combat bias in your datasets?
Yeah, that's a good question. I think we started with that. Like, are you are you doing your sampling part right? And again, are you looking with the right sheet? I mean, it's hard. And it's I agree with Seth. I mean, you're training your model based on historic facts. So yeah, if you're looking for crime, you will find it, right? I mean, you find where it were. So and as said before, I think we humans are already biased. So how can you get the bias out of yourself? And well, I think that's also a challenge in itself.
The data sheet concept is great in the sense that at least you're writing down your bias, or what you believe
and
your bias
intent.
is.
I think that's also nice.
Yeah, because you're never going to eliminate bias. The best you can do is label it. And so the idea that we would deliberately label, this is what we were thinking, this is what we, our approach, that also tells you all the things they weren't doing. So when you're going to look at that data, possibly for a different purpose, at least you know this was not the intent of this data. So, tread carefully.
Yeah, and then and now you mentioned also, I think, the intent of the data. That's also, let's say, a methodological problem, that you should use your data where you had the intent for. So you cannot just cross-use it without thinking. I mean.
Yeah. That's what I think the data sheet serves. Is like, are you to the purpose of the data from this original intent, or are you cross-purpose to it? And so some additional steps need to be taken.
Yeah.
Overall, I think it's fascinating that we've all of a sudden, we're now to the point where we have some pretty sophisticated models, and now we're stopping to think, hey, maybe we should be smarter about how these things are used and why and when and where.
But that's also pretty normal in human civilization. It's only when something reaches a certain point that we should have some rules, right? I mean, the car came before the driver's license. And well, it's only until we had a certain number of cars, it's like traffic lights. That's an idea, right? Standardization of controls, good idea. Like, all of those things emerge with the expansion of something. So I do think we've hit a critical point where we have so much data, where we now press against people's privacy and attention all of the time. And so those are now valued things, precious things, and things that need to be protected.
So for both of you, what are the traffic lights and the driver's licenses for machine learning or AI models? What do you think those should look like? What should they be? And we'll start with you, Miriam, and then we'll go over to you, Richard.
Wow, that's a hard question.
It is.
Again, an answer would be that depends. It depends on the algorithm. It depends on the problem you're solving. So based on the algorithm, you would have, I would say, different rules and different controls or stopping lights. I don't know. Maybe Richard, you can hop in, but.
Well, we've had a barrier to entry right now in complexity, right? Only certain people could be successful with this, that it took certain levels of skill. And that level is starting to diminish, is part of the reason that it's surfacing so thoroughly. What we're ending up with is a gatekeeper concept right now. And you're seeing the pressure on organizations like Microsoft and IBM and Google and Facebook and so forth, those that are largely serving as gatekeepers to the access to this data and these models, to say, take some responsibility on that. And largely, when you look at the partnership of AI, it is those organizations saying, we're going to pay attention to how these things are used and how they're being built. I don't know that it's a good solution, but it is, the current gatekeeper are the cloud providers.
Honestly, like just a simple, how sometimes in California, I lived in California for a number of years, and everything, according to the state of California, may cause cancer, and there's like a label on it, like
On
this
everything.
is known as this is known to the state of California to cause cancer, and you're like, okay, like just a label that says this decision that the computer is making is influenced by automatic models. Like just that label alone is helpful, right? Just disclosing the fact that you're using automatic methods to make decisions. I mean, that label helps a lot because then you're like, oh, well, why did it reject me? And then you can ask further questions, right? I mean, that's just to me like a simple, like tiny stop sign or maybe a speed bump. What are your thoughts on that?
Yeah.
It's the argument in favor of against the computer says. Right? Is to say, did you read the label? The label says the computer is only amplifying our own data sets.
Marion, your thoughts?
Yeah, I fully agree because, I mean, even if you take just a simple decision tree, I mean, they're normally very successful, right? But if they're wrong, you can be really wrong. And it's not without a risk. And let's not talk about neural networks, which are way harder to explain. But I see in practice a lot of people that are using, let's say, any alteration on a decision tree, not knowing that they can be wrong, right? And then the computer says no, but maybe it should be yes. So yeah, there is a risk. And I would say it's a probability, right? I think we have to make clear to people that it's not a yes or no, even if we convert it to yes or no, but we're talking about probabilities.
Richard, and I like the way you put it, though. Like adding a disclaimer in really small print is not really a good idea either. I guess I'm just trying to, in my head, figure out what's the license look like, what's the stop sign, what's the stoplights, you know.
Well, I don't want to fight you on that because what I want is and no one to be accepting of the response, well, the computer says.
Yes.
Right? Because that's a terrible answer and it should be immediately challenged. I kind of want a little business card that says computers are often wrong. Right? It's just you want to press back against that because they are only ultimately tools that we manifest in the first place.
Cool.
But you know, our industry is still not a profession. The computing industry, right? We don't have a professional certification. We don't have a group that is ultimately responsible for when its members make mistakes. You know, it's the difference between a software engineer and an electrical engineer or a civil engineer or a doctor or a lawyer, that they're always backed by a group that certifies them and takes responsibility for them. Right?
Yeah,
and we've largely been isolated from that.
Early on, I worked at a place that I was the software guy there, at a place that served actual civil engineers. Mm-hmm. And I remember one time one of their engineers came in and I was like, oh yeah, I'm a software engineer. He's like, are you? Where did you get your certification from? Where's your license? And I was like, oh. And I obviously I was a young guy still in college then, and I took offense to that. But many years later, I came to the realization that if a bridge breaks and someone gets hurt, there is someone that's accountable.
Yes.
Not only the person who built it, but the state organization that certified it.
Yeah, and the authority and the certifying body, you know, that's the nature of it. And you understand, software, through the end user license agreement, has obviated that responsibility, and for a good reason. It allowed for rapid innovation, right? And you know, we didn't start out with rules for buildings. We just got to a point in sophistication of buildings where falling down had serious consequences. Like, we should have rules. We are now reaching that point in software. Like, there's a question of when do we become a profession? In exchange for decelerating innovation to increase reliability. Right, that's the trade we're going to make. The aerospace engineering field still innovates slowly, carefully, because the consequences of being wrong are serious. Software is running the world. These models can shape cultures. We may need to be taking more responsibility for that, and that means changing that rule, exchanging rate of innovation for safety.
And that's an interesting thought process. I mean, is it something we should be doing in AI as well?
Well, I think AI has brought it to the light, right? We're seeing the ultimate manifestation of computing so far, right? There are more manifestations coming. When you start seeing the potential of quantum computing around its changes to the way we'll approach chemistry and different physics models and so forth, that also may be a new class of concern. As we get better at this, as the same way that when the car got faster, the rules became more important. The potential of computing is growing, the rules are becoming more important.
Yeah, I mean, there's certain systems that literally could be like a bridge falling down effectively.
Sure. Right? You think about the efforts we're going to well, you know, our water supplies have technology in them now, right? They're not just pumps and valves, there are computers there. There are computers on every one of our power plants. You know, I'm doing these shows over in Runaz land and .NET Rocks land, talking to folks that are talking about how to SCADA systems get integrated onto the internet and the security consequences that represents. You know, the reality is that an awful lot of our civilization depends on an awful lot of compute that needs to work. And so we are in a transitory period now. I suspect we are the generation that will see us become a profession.
Interesting. And like, when you say that, do you mean like in the next 20 years kind of thing?
Yeah.
The next 5 years? Okay.
I mean, it's hard to predict exactly how quickly, and there's a bunch of different models of how to go about this, and that's a whole other show. But I think that artificial intelligence is just this mechanism now that's showing the power of compute, and some of it unfairly, right? We get into the anthropomorphic things, the Terminators, all that silliness. But it's also useful for the public's fear to say, how are we licensing this? How are we controlling this? It's always actually been a concern. It's just becoming more acute.
Interesting. Marion, as you build stuff, because like clearly you build stuff. I'm a demoware person, and I have been for many years. Do you think about these kinds of things as you build stuff with you and your colleagues?
Yes. As mentioned before, maybe just in a very simple form, but to write down everything you make a decision upon, so somebody else can check that with you, can go through it. Also for yourself, I mean, as you develop as a person, you can look back and say, hey, I made this decision, and contributing to bias, basically. So yes, I am aware of it, and I try to minimize it to at least write down my decision, so somebody else at least can see what my intent was. And also, I normally put a disclaimer in my code, like that my intention for a model, because again, if you build a model to, for example, find out which student needs some help, right? You can revert it and say, hey, I'm going to exclude this student. So by including my intent in the code, it's like, yeah, this is the intention of the model, so please use it rightfully. I don't know, we don't have specific rules yet for that. I think I completely agree with Richard. We don't have the licenses, we don't have the controls, but at least I think we have to be, you know, we have to maybe make them and try to make them, and maybe future generations will build upon that. But you have to be aware of that. As a developer, I think, you mentioned it, Richard, I think you always have to take your responsibility. How far that goes, I mean, I don't know, because if somebody takes my models and implement it in a way and abusing it, that's hard. I mean, but in theory, you can do a lot of damage. You can do a lot of good, but the same way you can damage a lot. So not only to protect, let's say as a driver, you also put your seatbelt, right? So you want to protect yourself too. But also at least to make sure what your intent was and the decisions you made.
So before I go to Willem, one last question, because I know I've been hogging you all. Let's start with you, Marion. What's the future of AI? And then we'll go to you, Richard, on that.
Well, what I hope, I mean, I don't know what the future is because I'm not a visionary, but I hope people will see it as a tool and not forget that they're human. So yeah, it's great technology, so you can do a lot of things, but please don't forget that you're a human being and you can use technology to do better things. But again, don't just listen to a computer.
Yeah, Richard. I can't argue with anything you say there, Miriam. It's, These are just tools, and we've created a new set of tools that are empowering people to do. No, absolutely.
Ah, cool, 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 cool.
Y'all are the best. Thank you so much.
Okay, we're back. Thank you very much, all of you, for joining us. Thank you, Richard, for the awesome session and the panel discussion afterwards. There's a lot more stuff to talk about, I'm sure. But we're out of time. And with that, I would like to announce the winner of the $50 gift card for Amazon. MB Findenberg, you're going to get a message from us because you had an awesome tweet. There's no doubt about that. We will make sure that we retweet that and make sure that it's going on my wall, I think. That it's that good. So thank you very much, everyone, for joining us. Next week, we are back on Thursday again. Same time, same place. Hopefully with a better internet connection and better microphones and everything. And then we're going to talk about computer vision. We've got awesome people joining us. So we've got someone from OpenCV, no less the CEO of OpenCV, Satya Malik, who's going to talk to us about their new AI innovations. Actually, a camera that can run deep learning models. So that's really cool, I think. And we have Elizabeth from Cisco, who's going to talk about micro interactions and what that means for building AI models in computer vision. It all sounds very, very cool. So we'll have lots more demos to show, a lot more stuff to go through. I mean, thank you very much. Have a nice evening or morning or afternoon or wherever you are. Seth, do you have any final words for us? Any wisdom that you want to share with us?
Yeah. Life is awesome. Go forth and make cool things.
Cool, cool. Thanks. Have a nice day.